This is how big of a balloon you need if you want to go flying through the air with either helium or hot air. Lifting force of helium, about 1.1 kilograms per cubic meter. Let's say we got a person that's just going to use a lightweight lawn chair and some lightweight helium balloons with string tied to that lawn chair. So he'll just have 100 kilograms total that he needs to lift. Helium can lift 1.1 kilograms per cubic meter. The kilogram divided by kilogram cancels out. You're just left with cubic meters. You need a balloon about 91 cubic meters. 1 cubic meter is just a box that's 1 meter in all dimensions. Let's say this balloon is a perfect sphere. So let's find the radius of that sphere. The formula for the volume of a sphere is 4/3 pi r cubed. We know the volume to be 91 cubic meters, so let's solve for radius. You'll get a radius of about 3 meters, which is a diameter of about 6 meters, or about a 20-foot diameter of your helium balloon. That's about the width of a large master bedroom and about the height of a 2-story house. Next page. Say you don't have any helium laying around your house, but you got some burners and propane tanks and a bad idea. You can just use some hot air, which is nitrogen and oxygen, into an O2. That'll give you a lifting force of about 0.37 kilograms per cubic meter. In addition to the balloon, you'll need a basket, burners, tanks, and a person that hopefully knows what they're doing. I got all sorts of numbers for the minimum mass that a hot air balloon would need to lift, from anywhere from about 400 kilograms up to about 1,000 kilograms. So let's say this will be a small basket and small setup, so it'll just be 300 kilograms. The person would be about 100 kilograms of that. Feel free to plug in your own numbers because you'll likely find something more accurate than I did. At any rate, take your 300 kilograms that you need to lift in the air, then take your ratio of 1 cubic meter per 0.37 kilograms for your lifting force. Kilogram divided by kilogram cancels. You're left with cubic meter. You'll have about 811 cubic meters of volume of the balloon that you will need. Solve for radius the same way we did last time. That'll be about 6 meter radius. Gives you about a 12 meter diameter, which is about a 40-foot diameter. That's about the height of a 4-story building. Next page. Here's some minutia. Take your lifting force of your hot air divided by helium. 0.37 divided by 1.1 gives you a 1:3 ratio, or 1/3, showing hot air has about 1/3 of the lifting force of helium per volume. Let's take your volume times your lifting force per volume, and that'll equal the mass that you can lift. Volume times mass per volume. The volumes cancel. You end up with mass equals mass. Divide your mass by your lifting force per volume. Mass divided by mass per volume. Masses cancel. You're just left with volume. Hot air requires 3 times of the mass, about 300 kilograms instead of 100 kilograms compared to helium. Yet hot air has about 1/3 of the lifting force. 3 divided by 1/3 equals 9 times the volume of the balloon you'll need if you're going to use hot air instead of helium. Let's take our actual numbers. Hot air balloon had about 811 cubic meters of volume. Helium had about 91 cubic meters of volume. That's about 9 times the volume. So it looks like a hot air balloon will have at least 9 times the volume of a helium balloon. But the trade-off is hot air is much cheaper. See my full video if you want to see how to use subatomic particles and high school algebra to calculate the lifting force of any gas.